In this video, we're going to look at scientific notation. Before we do that, we review what we learned before about exponents, positive exponents and negative exponents. So we have learned what it means. So for example, if I have 10 to the fourth, if the exponent is positive, it means we multiply 4 copies of 10. So we have 10 times 10 times 10 times 10. It gives us 10,000. And similarly, if we do a negative exponent, what if we have 10 to negative 4? And negative exponent means reciprocal. So that means first we're going to do 10 to the fourth, and then flip it. Flip 10 to the fourth. So we again get 1 over 10 to the fourth. And we work out the bottom, 10 to the fourth. If it's positive, it means 4 copies of 10. So on the bottom, we're going to have 10,000. So it's 1 over 10,000. And suppose we do it by decimal, 1 divided by 10,000, which means the quicker way to do it is to move the decimal point to the left 4 times. So I'm going to add a bunch of zeros here so I can move it 4 times. 1 does not have a decimal point, but it's considered as 1.000. So we're going to move that decimal point from the end to the left 1, 2, 3, 4 times. So the decimal point is going to end right here. So the answer is, if I write it better this time, it's 0.0001. So that's the number either in the fractional form or the decimal form for 10 to the negative fourth. And the quicker way to look at it, if it's a positive 10 to the fourth, we're going to have 4 zeros after 1. But if it's negative 4, we're going to have 4 decimal places, including that 1 there. Now, so scientific notation is an application of the exponents. And so usually in astronomy or in physics class, we may have seen numbers of a very huge number, say the distance from the Earth to the Moon, or the speed of the light, and it could be a very big number. And when we write a big numbers like that, and it could we could, because it has so many places, and it's possible to miss a zero somewhere, or and also it's tedious to write such a long number. And so, for example, if we have 23,400, and this number actually is not too bad, but we can use this as example to discuss the scientific notation. And we may have a bunch of zeros in the end. We can look at them as the next example. So what we do is we can clearly, this can be written as 2.34 times 000, because what we do is, if we can verify that we have, when you multiply a number by 10,000 with the 4 zeros, it's like moving a decimal point to the right 4 times. So say 2.34 has a decimal point right here. If we move it 4 times, we're going to get 1, 2, 3, 4. That's exactly 23,400. So why do we write like this? Because we know 10,000 can be written as 10 to the fourth. So we can just simply write a number as 2.34 times 10 to the fourth. So instead of writing all the zeros. And similarly, when we have a huge number, like if I put a bunch of zeros in the end, and now again, this, when we have such a long number, it would be more convenient to use the exponential number, and we call this a scientific notation. So what we do is we would like to have a number, this number between 1 and 10. It can be equal to 1, but it has to be less than 10. So it's kind of like greater than or equal to 1 but less than 10. Maybe I should put, so this number has to be between less than 10 but greater than or equal to 1, whatever this number is. And so what we do is we start at the end of the number and trying to move to the left. 1, 2, 3, 4, 5, 6, 7, 8 until we reach a number between 1 and 10. If we move 1 further, we're going to get a decimal 0.234, which is less than 1. We don't want that. And also, you don't want to stop at 23 because that's bigger than 10. So we're going to stop between 2 and 3. And that will give us 2.34. Write down the number. The zeros can be omitted. And remember how many times we move it. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to multiply by 10 to the 8th. And so in this case, when we write down the big number like that, and we won't make mistakes, we won't miss the 0, because if you remember it's 10 to the 8th, we won't ever miss a 0 or add extra 0. So that's how we write down a huge number like this, and we can write it as 10 to the positive exponent. But in the medical area, we often have like very small dosage. Where in biology, we may have the atoms or molecules with a very small size, and so we could have numbers very, very small like this. So let's try maybe 3, 5, 7. And again, similarly, this time we're going to move the decimal point to the right, so we can get a number between 1 and 10. So what we do is, so start from this decimal point we have and move it 1, 2, 3. We can stop right here because 3.57 is a number between 1 and 10. And then we write down the number of times we moved as a negative exponent. So 1, 2, 3. This will be multiplied by 10 to negative 3. And we can verify this is correct. Because 10 to negative 3 means 10 to negative 3 means 1 over 10 to the third. Negative exponent means reciprocal, and which means 1 over 1,000. And that the decimal. So when we divide, so this is like times. Well, we can change it to decimal to 0.001. 3 zeros means 3 decimal places. So when we multiply, so this number is 0.001. If we multiply 3.57 by 0.001, that's going to move the decimal point to the left 3 places. Because in the answer, we should add together. So there it is. So 3.57 times 0.001. Together, we have 2 decimal places here plus 3 decimal places here of 5 decimal places. And if you look, 1, 2, 3, 4, 5 decimal places in the answer. So that's how we write it. And we can look at another very small number. So we can add a bunch of zeros in here. So if we have 0.0000001,2, and we can write it in the scientific notation. So by moving the decimal point, 1, 2, 3, 4, 5, 6, 7, 8. So we stop right here. 8. Because we're moving to the right, we're going to do negative exponent. So when the number is very small, 0 point something something, you're going to multiply by 10 to a negative exponent. But if it's very, very big, you're going to multiply a positive exponent. So that's scientific notation.